Just looking at drive motors for trains, there's two forms. There's AC, I'll start again. Just looking at drive motors for trains, there's two forms. There's AC motors, there's DC motors. AC motors, as you know, have the windings around the outside of the motor with the stator in the middle being magnetic steel with low magnetic permeability. In other words, it creates a magnetic field easily, loses a magnetic field quickly. DC motors, as you know, have got a permanent magnet or large windings of copper around the outside to generate a magnetic field, with also windings on the armature in the middle of the motor as well. AC motors weigh a lot less than DC motors, which means the train carriage weighs less, which means it needs less power to drive it. Regenerative braking happens across both. It might be something as simple as a heater on top of the train carriage, which just as the train is coasting down a hill and there's no power feeding into it, the motor, as you know, in reverse turns into a generator. It might be just releasing that extra energy it's generating as heat on top of a train carriage, as how some trains regeneratively brake. Other trains feed the electricity through the pantograph back into the supply line, which then goes to another train. That is probably far preferred as an operator of a rail line to regenerate the electricity and capture it and use it on another train, but it all depends on the cost. Modern trains even have a supercapacitor and a battery. So let's just put a capacitor. There's a symbol for the capacitor there. And they just store the extra charge in a ginormous capacitor. Then when the driver hits the go button again, it pulls the power out of the capacitor before it starts to draw it out of the network. Lithium batteries mean that trains can now carry a small battery with them. Covers momentary interruptions in supply, and once again, regenerative braking feeds the battery. AC and DC both can do it these days with AC control. Starting torque is a lot higher on a DC than an AC motor. It's one of the big advantages of DC motors is that they can be used to power freight trains quite happily. Brush maintenance. DC motors, as you know, have brushes that create carbon dust, carbon everywhere. They need frequent maintenance. They're more expensive to operate. So, brush maintenance, and every time a brush sparks, it releases ozone. Ozone is highly oxidising, which means there's a lot of corrosion in the vicinity of the motor. So DC motors are not good from that point of view. Maintenance needs are obviously higher then on DC than they are on AC because of the brushes, the brush maintenance, the general carbon dust that's produced everywhere. Reliability. Because of the maintenance issues, DC motors tend to break more often, or tend to fail more often. Because they fail, AC motors are far more reliable. Efficiency. AC motors are far more efficient than a DC motor. Efficiency is power fed into the engine unit versus effective power that makes it to the wheels. AC motors have far better slip control on the wheels. They're controlled using variable voltage, variable frequency drives. So they're variable voltage, variable frequency drives. DC motors are essentially controlled through resistors. I don't imagine that you'd be looking at pulse width modulation on a train that's using kilowatts of power, as in 400 kilowatts, 600 kilowatts. I can't imagine the control unit is that good. And the initial cost, AC is higher than DC because of the control circuitry. There's your comparison of the two forms of motor. Most modern trains use AC. The advantage in DC is start-up torque. That's the one big advantage of DC compared to AC. Other than that, AC wins hands down. high speed, efficiency, AC, operating costs, AC. Train companies tend to go with AC motors where possible. Forgot to mention, trains might even have a diesel motor driving a generator. So there's our diesel engine, drives a generator. The generator makes AC power inside the engine. The engine then feeds that electricity through a control, two motors driving both bogies. So you might, or common diesel engines you see travelling through the bush are actually driving a generator, which then is used to, which then produces electricity. The electricity is controlled, and that is used to drive the wheels. Reason being, the electric motors and the electric motor control can handle a lot more power than a mechanical gearbox, unless the train is really, really lightweight and really, really small. So the only way you can get a diesel engine to drag a freight train to Melbourne is by having the diesel engine drive a generator and use electrical control circuitry.